Good afternoon, everybody, and very welcome to this webinar. This webinar is about monitoring solutions on LoRaWAN, and we are very happy to present this webinar together with MClimate, one of our favorite vendors. And Louis of MClimate will also take part in this presentation. He will introduce himself later on. So thank you for joining this. Let me first start with a few rules of the game, as we call them. You can ask questions, of course, and you can do so in the chat of this team webinar. Please note that you have to also enter your name with this question, because if you don't enter the name, a number of questions will not be answered, unfortunately. This webinar will also be recorded and afterwards sent to you, so you don't have to take any notes. But of course, if you do so, we don't have a problem. So let me first start a little bit about MCS. My name is Jan van Rossum, and I'm responsible for operations within MCS. And MCS is actually a company who is very much involved in managed IoT solutions and private network. So we are all working very hard to keep our customers happy with these managed IoT solutions. And if you look at what actually a managed IoT solution consists of, that's those elements right in the middle of this slide. So you start actually with sensors. These sensors, they collect the data, and this data is then forwarded to gateways. That's the other circle in this middle of the presentation. And all this data is then gathered by gateways and routers and pushed over a certain network. That's the connectivity circle, to a data analytics platform. Actually, that's the whole. Those elements. They form the total solution of a IoT solution. And then, of course, you also would like to manage all your devices, and you can do so by a remote device management platform. So all those elements we can offer to our clients as a total solution, but also clients can, of course, have certain elements themselves, and then we just offer the separate individual elements of that solution. We do so by offering those customer solutions by offering all those vendors on the left side. As you can see, MClimate is one of them, of course. And with all those vendors, we build these solutions for customers you see on the right side. So that's actually about the IoT solutions. We also have another part we offer to our customers, and that's about private networks. Private networks you can compare actually with the more public mobile cellular networks. These networks, you know them from Vodafone, for example, or T-Mobile. But then actually in a very small building, so to say. So for example, if you have a hospital or a care center, you can have your own private network, your own 4G or 5G network, where you can do all your business critical communication over that network. That can, of course, be data, but also voice via voice over IP apps. So those are our two main areas of business: IoT solutions and private networks. To give you a few examples of IoT solutions, you can think about if you go to an airport, for example, this is Schiphol Airport. We provided a IoT solution network, and they do all kinds of applications there. One of the applications is actually the what we call feedback now buttons. They use them in the bathrooms so that customers can indicate if a bathroom is clean or should be cleaned, because it's actually pretty dirty at that time. You also see, because of these networks that, and because of these functionalities, that Schiphol really changes the whole business model or service model. So in the past, actually, a cleaning company, they just did their rounds, like 4 rounds a day, but now they are actually really focused, more focused, and also paid by the results, actually. So it's more that they have to put some kind of an SLA, a service level agreement, that at least 98% of the feedback now buttons should be green, for example. So it's a totally different business model. Another example of IoT solutions is what we help with is the cleanup, ocean cleanup monitoring. Maybe you know it, the ocean cleanup, they gather all the plastics in the ocean. And actually all those segments of this large pipe here, they should be monitored by water leakage. So we built a very small LoRaWAN network on that specific object to measure all these elements, these pipes, if they had water leakage, and then of course that would be sent back to the shore. One other example of a IoT solution is also, well, you see here the so-called text cars. You see them on the highway. If you have some kind of work done on the highway, they indicate it on those text cars. And of course, you can only do so if you can remotely access those text cars. So that's what we also help with our IoT solutions. Another solution you can think of for IoT is monitoring of CO2, which is of course very actual since the whole COVID period. And luckily we have many schools which should be monitored, so we can provide very interesting IoT solutions there. We also, what I told you, do the 5G networks, private networks. And actually you see in this 5G area, you see the world of IoT coming together with cellular networks and private networks. So we can do all kinds of IoT solutions over that network. We have I think like 6 test labs, field test networks on 5G, where we do all kinds of tests for IoT solutions as well. But then, of course, on the new fast 5G. Another inspirational example of IoT solutions is actually wildlife monitoring. Especially with LoRa, this is also a LoRa solution. You can cover a very large area with just 1 or 2 gateways. So you can have, well, wildlife is of course, that's a large area where these beautiful animals walk. And then you can really keep track of where they are and of course prevent them from being hunted. So those are just a few interesting IoT solutions. I will now give the word to 𝗬𝗵 of MClimate to introduce himself and MClimate as well.
Okay, that's great. I'm sorry. So as I was saying, MClimate, I founded the company 10 years ago. We've been dealing with the Internet of Things since 2014. And, we had a slightly different beginning. We started with more of a smart home solution based on Wi-Fi. But then around 2017, 18, we found LoRaWAN. LoRaWAN back then was, in its very early days. But we were fascinated with the kind of the ability to penetrate through walls, and especially the ability to run for a long time on batteries. So, for those 10 years, now we have a proven track record. We have more than 500,000 devices already deployed somewhere in the EU, and we focus on high quality devices. We want to remain a product company, and it's very often that for example the case with MCS, we find one very good partner for a market, discuss the strategy, how to reach system integrators, how to equip those system integrators with our products. And one last thing about us is that we're, gateway and IoT platform agnostic, meaning that all of our products, they're typical LoRaWAN products, but they're very well documented. We also create some tools apart from just the documentation for you to better understand what is happening for you, for example, to predict the battery life, etc. But I'm going to go quickly over our portfolio. We divide it in 4 main categories. The first one is the indoor climate optimization, and this is where the kind of the ROI, the return on investment, really shines. Here we have the 𝗦𝘄𝗶𝘁𝗰𝗵 𝗟ci𝗥 is a radiator thermostat. It again works with LoRaWAN, has 2 typical AA batteries inside, but lasts for about 10 years, depending on spreading factor and how good the network is. On average, it should achieve 10 years. It gives you temperature, humidity, how open the valve in the radiator is, so how much hot water is flowing. It's a great product, and especially during the kind of the energy crisis that we experienced, we saw a lot of demand from the market for 𝗦𝘄𝗶𝘁𝗃. Then we have the HD LoRaWAN, which is a simple humidity and temperature sensor. Reports temperature, reports humidity from a digital IC, integrated circuit, and then it again works on 2 AA batteries. And then we have the wireless thermostat, which can operate on batteries. It has space for 4 batteries. But then in the meantime, this was our first product that had a solar panel. So this is a very special solar panel which harvests the indoor light. And essentially, for it, you don't need the batteries. You might want to use them. That's up to you. We left space there for batteries, but it was because in the beginning we were pretty skeptical. We were trying to be, more on the safe side. Now that we have so many of those deployed, we see that in most cases the light from the room is enough for it to operate. So here the question is, not when the batteries are gonna fail, but more like, how long the hardware itself is gonna last. But the wireless thermostat itself, it's a very simple device. It has an e-ink screen. You can adjust the temperature, the target temperature from the thermostat, and then you can route it to 𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏 push it into the BMS, so you can zone some buildings into multiple rooms. But it also has a movement sensor and a light sensor. And then the last device in the indoor climate optimization is the fan call thermostat, or as I call it, this is the kind of the hotel thermostat, because every time you go into a hotel and you see you can change the temperature, you can change the fan speed, you can turn the thermostat on off. It's most probably a fan coil unit behind it. So the fan coil units is kind of the most basic heat exchangers. There's a coil, and then there is a fan behind it. Through the coil, hot or cold water is pumped, and then the fan just blows into the air, into the room. But the fan coil thermostat, it features a large e-ink display again, and it's compatible with 2-pipe or 4-pipe heating systems. I call it a hotel thermostat because it's compatible with most of the existing hotel thermostats. Then the second category, we have the T-valve. The T-valve, it's a water shut-off valve, so you can shut off or allow the valve, the water to flow through the valve. It also has a temperature sensor of the water. It has magnetic tampering. The initial use for T-valve was by a utility that wanted to essentially shut off the water supply remotely in case somebody is not paying their water bill. But it's very nicely combined also with the flood sensor we have. So the flood sensor itself, it's a very small device which essentially when there is water below it, it detects it and then it alarms immediately. And then you can decide if you also have a T-valve, you can shut off the water supply and minimize the damages. Or if you don't have a T-valve, you can just alarm somebody and somebody can go. And again, still, they would limit the damages. It's one thing if you have a flood going for 20 minutes, and it's another thing if you catch it in 8 hours or 2 days. But this is about the water. Then we have the air quality and CO2 monitoring. Here we have 3 similar but different devices. The first one is the CO2 sensor, which is essentially a typical NDIR, so it gives you real readings of CO2, it gives you readings of temperature, humidity. It also has an acoustic buzzer inside, so you can define like if the CO2 goes above some level, you can say, okay, beep shortly or play this melody, for example. But it is a device that works on batteries. And again, here from the batteries, we expect 10 years of usage of life, essentially. Then we have the CO2 display, LoRaWAN, which is very similar to the wireless thermostat in terms of housing, in terms of functions. It shows you the history of the temperature, humidity, light levels, and also CO2. Again, features the same 2.9-inch ink display, and also has a PIR sensor, which is for movement. And then we have the CO2 display Lite, which is essentially a more cost-effective version of the CO2 display LoRaWAN, which features a smaller display, the same type and same size of a solar panel. This one does not have option for batteries because we realized, okay, light levels are enough in most cases. So we decided let's optimize the cost and create something that works kind of like the CO2 sensor, but has the display and also has no need for maintenance. And then the automation devices. Here we have a typical open close sensor. It is put on windows, on doors. So whenever a door is open, you receive this information almost immediately, a few seconds delay. Then we have the multi-purpose button, which when you click it, anything could happen. And the last two devices here are the 16 amp switch and power meter, and then the 16 amps dry switch. But I'm not going to talk about them now because I'm going to explain what are they and what is the difference later in the presentation. In terms of our business model as a company, we have essentially two ways to work. Either we sell only the hardware, where we focus on on quality and documentation. So here, by selling only the hardware, we essentially want to equip our partners with devices, with ways to connect to appliances that they don't have or didn't have before. But here you can integrate it into your system, into the BMS or whatever you want. And then at some point, we had to develop our own software as well. The MClimate Enterprise, it's an IoT platform for management of buildings, where you can monitor, you can control, you can get reports. But the thing about the Enterprise is that it only works with our own MClimate devices. It's not a general IoT platform like some others, but we did it so that people can really test with the functionalities that we envision for those products, the way that we envision that thin data should be displayed, and we just want to offer an optimum experience of our solutions across the board, not only the hardware but also the software. And the way we work with the market, essentially, we have distributors like MCS, for example, in some key geographies, but then the types of clients that are actually purchasing and then installing is we have a lot of utilities that are working with us, utility service providers, a few telecoms as well, and some facility managers that really see the value of IoT inside buildings. And yeah, we stay only inside buildings. We're not trying to be unfocused and try to cover everything. But we want to really, build this expertise in the building sector and help there. But we also have energy efficiency companies, or the so-called ESCO companies, which essentially like our products because our products are saving energy, and those companies are getting their essentially profit, as a percentage of the amount of energy saved. So the easier the installation, the easier the maintenance, and the better the savings. This is what those companies are after. And then we have the automation, the building automation integrators and sometimes SaaS providers, which really like the fact that first, our products are with open protocol. There's no vendor lock-in. We don't lock you to use our software. You can use whatever software you want. And the building automation integrators, they like the products because first, they're wireless. They feature LoRaWAN, so the network itself, you don't need a ton of gateways. You need a few to cover the building, but then those gateways can route the information from the wireless sensors directly into the BMS, so they can appear like it's a for example, a Modbus or a KNX, let's say a radiator thermostat. But in reality, you get the benefits from LoRaWAN, which is long range and very good battery life. And for the last 10 years, we've amassed very good network of partners, companies that are actively using our products and like them. And I think the thing that unlocked this scale for us was, honestly, I think it's two things. First is the battery life, because when you have 10 years of battery life of a product, then this unlocks also business models that weren't available before, because usually those companies later, they also take care of changing the batteries. But companies like those, they cannot have visits to a building every year, let's say, to change batteries. So for them, having the 10-year life of battery was the game changer. And then the second thing, which I think it's really important, is the fact that the network itself, it's the LoRaWAN network itself, it's less complicated, meaning that you need less amount of gateways to cover a larger area. But at MClimate, we focus not only on creating good products that answer some market needs, but also on reliability and quality. Going into these amounts of products that we manufacture, obviously reliability and quality, it's a huge topic. I'm going to wrap up about quality. So we got ISO 9001 and 14001 certified. We create the products with, so to say, install and forget mindset, because usually visits to a customer are very costly, €1,000 and more. And we are not the cheapest on the market, and there is a reason for this. It's because we're reinvesting into reliability and quality and also new products. But we've seen many projects where the customers are opting in for the cheapest hardware, and then the whole project turns very expensive and most of the times also fails. Something unique that we have is the ability to update firmware over the air, meaning that if we release a new firmware update, you don't have to send anybody to the building. You can just with a few clicks initiate the update, monitor the progress, and this really lays the foundation for success for the future for us. And then we approach the IoT engineering kind of like rocket engineering, which means that we're testing the limits, trying to make things explode, trying to find the failure modes of every product and every component of product. But through accelerated live testing and stress testing as well, by now, for most of the products, we have simulated more than 25 years of usage of the products themselves. It might be the rotation of a part inside a product, might be the relays that are clicking, might be something, we actually put them in those climate chambers, which rapidly change the temperature and humidity from very high to very low. And together with the Technical University here in Sofia, we have run those accelerated aging tests. And since we're a little bit ahead of time, I'm just going to say that ESG is a huge part of our philosophy, even before ESG got popular. But this is kind of, you can see it in the philosophy of the products. We're one of the few companies that are doing actuators and not only sensors. And I must say, actuators, things that are controlling, are way more challenging than just sensors. But we see that with actuators, you can save way more energy than just with sensors. And we have more plans about ESG, but also things like further ISO certifications. We have already acquired 9001, 14001, and 27001. And in some cases, with some of our OEM customers, sometimes we're even helped to higher standards, like let's say VDA 6.3, which is from the German automotive industry, about quality. So we have a lot of, as I said, a lot of successful projects. Some of them are very challenging, like in residential sectors. But in Finland, thanks to our partner Telecom, we have a very good success there. We have lots of hotels, offices, but also, campuses, school buildings, hospitals, all types of buildings. And here, just, a few wanted to show as examples. This is, Plaza hotels. And so far, they've saved for a year 31% in heating costs. We have Kemper, which saved about 30% with a fairly, small investment. Usually, those products, we try to make them so that the ROI, it's 1 or 2 years, but it depends on the price of electricity. In here, we have a hospital which they say they've saved about 35%, even more. And I think the potential to save even more than that is there. But it's really easy to unlock it, so to say, with just some little amount of hardware. And thanks to LoRaWAN, you can unlock those 30% that are very easy. And then from 30 to 50% gets a little bit trickier, but at least you have the foundation, so to say. You have the sensors, you have the actuators. Yeah, and here I'm going to hand it over to you, Jan.
Thank you very much, Louis. For all the visitors actually of this webinar, please note that this is also recorded. So if you have to leave a little bit more early, that's no problem. You will get the recording by email later on. And Louis is of course very enthusiastic about his products, but we have to keep track of the time a little bit. So I will move in and do a little bit of a deep dive of one of our cases, so that you can understand what is actually important when going to monitor buildings. And we use LoRa for that. So LoRa and smart building, why would you do that? So first of all, if you look at actually a few of the challenges you have in the current buildings, are those items I just indicated here. So what we see is that actually we get directives from the European Union where we really have to monitor and save energy. So we have to really comply to these directives. That's one of the drivers to do energy monitoring. However, actually, if you need additional sensors, you should cable all those sensors. That's very costly. Also, the installation of those sensors is very costly. So that's an important challenge here. And of course, actually, you would like to integrate all those new sensors in your existing BMS, your building management system. So that's a kind of a brownfield situation where you would like to fit your new monitoring needs into. That could also be pretty complex. So what is actually the solution? The solution is actually the wireless LoRa network. And of course, we sell this, so that's why we're very enthusiastic about it. But you will see how it fits this purpose. So first of all, it's radio, so you don't have any cabling cost. And I'll get back to that later, what you actually then need for covering your area. But it's really good. And of course, as Lubomir also indicated, it's battery driven and can be up to 10 years. It depends a little bit on the frequency of your data. But if you do the frequency, which is provided by the vendors, and which covers most of the use cases, then 5 to 10 years is easy. So that means less installation costs if it's battery driven. You don't need power, you don't need power sockets, etc. You don't need cabling. And because it's long range, it's a very inexpensive network infrastructure. So what I said, it's radio, so you just need a few gateways to cover a large area. Outdoors, it's even, you talk about kilometers, but also indoor is actually very good. And you will see that in a moment in one of our cases. And what I said, you would like to integrate with your building management system because you already have a building management system to regulate all kinds of devices, heating devices, for example, in the building. And that's why you also would like to integrate these new energy censoring or, for example, the 𝗦𝘶𝗶𝗁𝗵 as the thermostats of MClimate. You want to like to integrate it in your BMS, and LoRa can do so. And next to that, it's just not a one solution, one purpose solution. You can fit many sensors in such a solution. If you have the network, the LoRa network, you can actually do anything with it. So what is actually the architecture of such a network? It might be a little bit a difficult picture, but I'll just lead you through it. On the left side, we have all kinds of sensors. As you can see, you can be power sensors. Actually, all the sensors Lubomir just talked about, like CO2 sensors, actuators, etc. They are all actually covered by the gateway you see at the second step on the left, where it says LoRa. So you have like 4 or maybe 10 or maybe just one gateway if it's a small area. And this gateway is then actually connected to what we call a IoT protocol gateway. That's one of the solutions. It can push the data directly to the cloud, but it can also push the data or catch the data, actually collect the data locally on a IoT protocol gateway. And this gateway is then connected to your building management system. So there are already default protocols here like BACnet, MQTT, and KNX. They are already included and can easily be implemented by just configuring the web interface. But on the other hand, you also have Node-RED, and there actually are totally free to use any protocol like OPC UA or Modbus or Siemens S7 protocols. So in that sense, actually, you're very flexible in integrating the whole new LoRa centering network into your building management system, or just push it directly to your own cloud solution like AWS or Google or Azure. So, okay, if you talk about a use case, for example, we have here a very large building. It's in Rotterdam. It's a very old building. And as you can see, it's a very, well, how you say, dense building. It has a lot of concrete. So that's actually pretty much of a challenge to get it covered, we thought. However, we did measurements for LoRa. And there you see that just actually with only 4 gateways, if you place them in a good situation, so to say, then you get the whole building already covered with 4 gateways. That's actually pretty incredible with such a large amount of concrete. So this is a use case where the customer will use 2,000 𝗏𝗏𝗏 radiated thermostats. And actually, because of those 2,000, we need more gateways because duty cycle radio, we have some kind of a limitations on the radio. So we need a few more gateways, probably around 10, but then still it's actually pretty cheap infrastructure to get this network running and measure all the interesting, or monitoring all the interesting energy and climate sensors. And actually, indeed, in this specific example, we integrated the whole system into the local building management system. So the customer is able to directly control all his thermostats from all the information he gets from the whole system. Another example is actually a school, and as you can see, I also picked this example because the building itself is pretty complex, as you can see, also pretty old. So infrastructure, getting new cables in there will be very costly, but just actually with 2 indoor gateways, we could cover the whole area, and we now read out like 60 CO2 temperature and humidity sensors throughout the whole building. So as you can see, this is actually a pretty cost-effective way of monitoring and complying to the new needs and even to new European directive. Well, this is one of the examples, but actually also because of COVID, we have now more or less like 30 school buildings with more than 1,000 sensors. So you can see how easy and cost-effective this kind of networks are, LoRa networks, to monitor climate and energy in all kinds of buildings. So those were a few examples and a setup of such a system to give you a little bit of an indication how that works. And actually, I will hand over to Łukasz.
So yeah, we get to the topic of the webinar, which is like the 2 new products that we launched, which is the 16 ASPM or switch amp meter, and the 16 ADS, which is the 16 amps dry switch. I'm just going to show them quickly. I hope you can see my screen, my camera, but this is the 16 ASPM. This is essentially 16 amps of relay and also a power meter. And just for a comparison, I'm going to compare the size with my Apple headphones. So you can see it's quite small, quite compact. And the why we did it, first we did it 16 amps so we can cover most of the EU countries and their legislations for the power outlets. Second, we made it so small that so that you can fit it anywhere. But I'm gonna get to this slide a little bit later. First, I want to talk about what is the difference. Here we have 2 products which look very similar to each other, just the color is different. But then the functionality itself is different. So in the 16 amps switch amp power meter case, we have essentially 220 or 24 volts DC input. Then this goes through an electricity meter. Then here is the relay inside, and whenever you switch on the relay, you see the power here. But essentially, with those 2 products, you can control and monitor anything you want. It can be a water heater, it can be anything. I'm gonna talk about the applications later. But then what is the difference between this one and the dry switch? So in the dry switch, essentially the power supply is independent of what you want to turn on and off. So here you can, let's say, power it with DC voltage, let's say 24 DC, but you can, control a circuit which is, it might be digital, might be 220 volts, but it's completely separate from the power supply of the product. So as I said, in this case, the power supply, enters, then goes through the electricity meter, and then goes out. And then in this case, essentially, those two are separated. But both devices are LoRaWAN class C, meaning that they're listening all the time. They still send data every, by default, 10 minutes, but you can change the frequency if you want. But the thing is that since they're class C, you can send commands and then they essentially happen in real time. As you send them, this is when the device receives them and executes your command. Both devices support either AC supply, power supply, or DC power supply, which makes them very versatile. And then the max switching current is 16 amps for the AC and 10 amps for the DC. In terms of switching power, 3.8 kilowatts of AC and then 300 watts of DC. Both of them feature the firmware upgrade over the air. So if we change something, if we launch a new firmware, no need to visit the building. And then the 16 ASPM, it also has the electricity meter, right? So it's it gives you the actual usage in terms of kilowatt hours. It gives you the voltage of the network, the current that the appliance is drawing through the relay, and also the power. And then the relays we use in those products are UL and Q certified. The electricity meter itself is it has MID accuracy, which is MID's measurement instruments directive. So it's the same directive that says, okay, you can put it and start billing people, create invoices based on this data. But in this case, you cannot. And the reason is because we cannot certify it. To certify a device with electricity meter, you have to have a display. And we decided we don't want to put a display on this device. We just want to make it as compact as possible. And then the terminals themselves, which are right here, those are from a very reputable, high-quality manufacturer here in the EU. And they are UL and VD certified, where VD is kind of the German code for electrical installations. And then the products, both of them have over temperature protection, meaning that if you have not wired, if you have not screwed the terminal well enough, and then there is increased resistance, the device is gonna see it and it's gonna power off the appliance based on the temperature. So it's set at 85 degrees, which even for 16 amps, which is the maximum, it's hard to achieve those. But then the 16 ASPM also measures the voltage, the power, and the current, and you can set different protections based on those. But just to reiterate, both devices look the same. They have the same size. Both devices have firmware upgrade over the air. Both devices have overheating protection. But the key difference is that the 16 ASPM, or the 16 amps switch and power meter, it has a power meter inside, and it's a live switch. And then the 16 amps dry switch, it is what it says. It's a dry switch, potential free. You can switch whatever you want, but it also doesn't have electricity meter. And just about a few use cases that we thought about. You can control things like electric heaters. You can just put them directly into the outlets, maybe to control, maybe to monitor. You can control underfloor heating, be it wet, with liquid, or be it electrical underfloor heating. You can control fans or ventilation systems. You can control water heaters, and I guess way more things. But our key use case, the thing that motivated us to create those products was the electrical space heaters. Because in some of the buildings, some of the partners that we have are approaching buildings that are not using fan coil units or radiators, but they were using electrical space heaters. So we had to come up with a solution for this. And in this case, the 16 ASPM, since it also measures the usage, can be paired with a wireless thermostat, so that on the wall we have a beautiful looking battery-free thermostat that can also monitor for occupancy, but you can adjust the target temperature from there, and then it also measures the temperature and instructs the relay whether it should turn on or off the heater. It's not yet public, but we're preparing to also launch direct device-to-device communication, meaning it's not going to go through the LoRaWAN network. There's a little bit less latency and more reliability, but I'm not going to talk in details about that. Both devices are supported by some of our partners in terms of IoT platforms. But both devices have their protocol fully open, well documented. And if you have any questions, our support people are ready to support you. And again, both devices can be used for direct integration into BMS, so that they appear as a BACnet device or a Modbus or even KNX at this moment. And then about the installation, I just want to mention a few things that I view as important. Obviously, first, this is directly from the user manual in the product. But when you install those products, obviously respect the electrical code in your country. So turn off the breaker, and very important, use the right conductor to handle the amount of power you want to control. So the bigger the power, the thicker the conductor should be. Our terminals, they support up to 4 square millimeters. Then second, don't put 2 terminals into one place. I'm gonna go a little bit back to this slide. Here on the 16 ASPM, you can see we've put actually 2 terminals just for easier wiring. They're the same, they're both N, but essentially don't put 2 cables into the same terminal, because we don't support this. And yeah, here I wanted to show that essentially the product, they have a button. With the button, if you hold it, you're gonna trigger a rejoin to the LoRaWAN network. But if you click it 2 times, it's gonna essentially switch the state of the relay. And yeah, this is how the product looks like. The LED tells you what is happening. Essentially, when you first turn on the product, it starts blinking. That means that it's trying to connect to the network. And then when it's solid, it means that it has connected to the network, and essentially you're done with your installation. And just for the technical people out there, the ones interested, I wanted to show a few graphs of what we receive, what you are going to receive as data from those devices. So here we're looking at a logo, which is placed on top of the building. And we control the logo based on the time. And you can see the blue regions is regions where the logo is on. It's on a timer. I think it says 5:30. It turns on, and then it turns off in the morning at 7. But so if it's blue, then it's on. You can see this green line, which is the accumulated energy. This is the electricity meter. So every time it's on, it consumes energy. You can see the red line, which is the temperature sensor inside the device. And then on the top, you can see the voltage, current, and the power. So in our case, we have a stadium next to us, and sometimes you can see when there are football or some type of games played on the stadium, we get a little bit of voltage decrease because they turn on those big lights. Yeah, well, this one is interesting because this is attached to essentially a few desks in the office. And here we can see, based on the current drone, we can see when somebody went into the office. We can see when they go, for example, here, they go on lunch break. It's just some interesting data that, you gain with those devices, even though it stays somewhat hidden. But you can also control and see how much you're using. But what's interesting to me is that you can kind of spot things that I didn't think we could spot before. But okay, that's it from me. So I'm gonna leave it to you now.
Well, thank you very much, Łukasz. I think it's a very interesting to see what kind of device it is and where it can be used. So we would like to take our visitors a little bit through the how do you get started with such a project? I mean, there's so much potential in there, but how do you start? We take you on a small journey, actually, and it starts really with what would you like to monitor, and especially why would you like to monitor it? What is actually the objective? And you really have to first determine that, because otherwise you just start doing all kinds of proof of concepts and then you end nowhere. So, for example, the objective could be that you have more buildings, several buildings from a certain retail chain, for example, and you would like to benchmark the energy consumption of all those buildings. So let that be the objective. Then, of course, you would like to know what is actually the value of that information, because in the end, everything costs money. But if you don't know what the result is of this solution, what the value is of that, then you cannot really judge the investment which is needed for such a solution. So, for example, if you look about these benchmarks, then you might be saving 1 or 2% or maybe 10%. So suppose you would save 5% of that total energy consumption of all your buildings, then you can really have a good estimate of what this solution might cost you for an investment. Then, of course, you really have to question yourself, okay, what kind of information do I need then actually, and for who do I need that? So who will use the information and in what form? Is that a kind of a report, or is it an Excel format, or should the information be injected in some kind of an ERP system? That's really important to determine, so that you can you can actually collect the data and get it ready for that system and the reporting form. And the final step is actually, okay, if I know what kind of information I need, where can that information be obtained? So if you're looking at this energy consumption, then you might really look into for each building, okay, where is this energy information actually collected? Are there certain meters already in there? Is that maybe reporting from the energy company itself, etc.? So you really have to look for where can I find this information and what kind of sensors do I need for that. So if you know all that, then actually you can really what we call follow the IoT train. And we'll just click through it, because actually the train is here at the bottom. So the IoT train goes from sensor to actually reporting and analysis. And in each step, you really have to define for yourself, what do I really need? So for example, sensors, if you look at this benchmark, energy consumption for benchmark, there might be already energy meters in your buildings, but they are Modbus, for example. So you would like to collect the Modbus data and then push the data through the LoRa network. So you need specific sensors, or you need specific devices who can translate that data, do some kind of protocol conversion, what you see over there, and then get the data on LoRa. Then you also can really think about what kind of network do I need? Is it actually LoRa, or might it be another network? It might also be 4G or maybe Wi-Fi, but that really depends on the frequency, and is it battery driven, etc., etc. But depending on the type of sensors, the terminals and the gateways, you can also determine for yourself what kind of network you need to transmit the data to your data lake or your reporting and analysis platform. So that's actually the final step. So when you retrieve the data, you need to process it as well, and you need to visualize it or report it to the ones who wants to receive the data and does something with the data that you determined in one of the previous steps. Or you might also want to integrate it with other systems. What we already talked about, Lubomir also, is that you would like to integrate it in your building management system maybe. Or you would like to integrate it in your CRM or Salesforce system, or maybe you want to do something with Power BI. So those kind of integrations you really have to think about on beforehand, because then you know into what form you would like to process the data so that it's ready to be retrieved by the receiving information platform. And last but not least, I mean, if you talk about LoRa, you might want to do this energy consumption business cases. If that's the application, then if you have this LoRa network, you can also think about other applications on that same network. You already have the infrastructure, so why not use also, for example, climate measurements like CO2 or all the other sensors that Lubomir talked about. So, for example, these water leakage sensors that might enrich your business case while you already have the existing infra. So you don't need any additional investments for the infrastructure of your network. So that's actually more about LoRa, and with this we came to the end of the presentation. So here we got some contact details, and of course we also have room for questions. And I have a very good assistant here. She already passed on some questions by the analog way. Let me see. Well, one of the questions here is: are there any plans to let the device switch for a certain time? So actually, it's probably the background would then be to use the dry switch as a gate opener, for example. Okay, so the question, the one who put the question here is probably asking if you can set some kind of a clock into the device itself. Well, Louis, maybe that's a good question for you.
So right now you can send 2 different commands to the device, but this doesn't work so much. We got this request a few weeks ago, and the firmware developers are already working on this. So hopefully in the next firmware release, you're gonna have the option to say, I want to turn on the relay for 15 seconds, and then it should go off. So the case with garage doors, with gate openers, it's gonna be covered. Yeah.
Okay, so but can you then do so in the device itself, or do you have to do that through the network?
Right now you have to send a downlink which says, okay, open the gate, open the relay, or close the relay for 15 seconds or 20 seconds and then go. Okay. Right now we don't have any timers, so to say, inside the devices. I think we're going to leave the timers for a little bit later, because we want to see what type of essentially use cases we see, so we know how to engineer them in the right way.
Yeah, great. All right, thank you very much. I also see another question. One of the guys asked us, okay, there's also something called like public LoRa. So, for example, in the Netherlands, we have KPN, who has a public LoRa network, and maybe I can shine a light on that. Of course, you can go with the public LoRa as well. However, what we see with our customers, if they have like 2 or 3 sensors just for temporarily measurement, for example, and there's good coverage, indoor coverage, then you might go with public LoRa. However, most of the times it's actually a dense, how you say, a certain building where you would like to have all kinds of coverage. And then the coverage of the public operator is not sufficient to cover all the areas in the building. So, and also from a cost perspective, actually, if you just need 2 gateways, maybe or 1 or maybe 2 to cover the whole area, from a cost perspective, that's actually far more interesting than if you have 60 sensors, for example, on the public LoRa as well. So it's depending a little bit on the case, but I think that private LoRa is most of the times is a better solution for you, and also because you're not dependent on the public operator. For example, in Belgium, they already stopped Proximus. They also had LoRa, but they stopped with it. Well, that's not the main reason, of course, but it can also play a part in your decision. Let me see. Oh, I also got the question here. Why shouldn't you just use Wi-Fi? Because that's actually also already covered in the building. Maybe, Lubina, you can indicate that. Why rather LoRa instead of Wi-Fi?
Well, I mean, if you want to do something like do it yourself for your own home, absolutely use Wi-Fi. But imagine a hotel which they rely on their heating to smart thermostats. And then if they're Wi-Fi and there is an issue with the Wi-Fi network, and Wi-Fi, you have a lot of people connecting, it supports the whole, let's say, hotel, then you might have an issue. And then it's another case as well, devices with operating with Wi-Fi, because there's plenty of smart home devices with Wi-Fi, right? but their batteries are advertised that they last for 2, maximum 3 years. In reality, 1 to 2 years maximum. So, I mean, for some business cases, if you want to create a business and you want to have this reliability of the network, I would never advise on Wi-Fi. It is cheaper in the beginning, but this is in the very beginning because you already have the gateways, right? But as you said, Jan, once you roll out this LoRaWAN network, which is, it is not expensive, but once you roll it out, you can add more and more use cases. So I think LoRaWAN, in the long run, it's definitely going to be cheaper and causing less problems than Wi-Fi. And definitely the batteries are a big issue. If you have to change batteries every year, you're going to spend more on batteries than on a single gateway.
That's right. That's pretty costly. I also have another interesting question here. Actually, one of the visitors is asking us, does the device automatically send back its I/O status after you send it a downlink?
Yeah,
so can you activate the I/O or trigger the I/O status by a downlink?
Yes, you can switch the relay on or off based on downlink. This is the main application, right? We have paired buttons, the multi-purpose buttons, and now we can control every light in the office individually. But yes, the moment you send the command, the device, since it's class C, it hears it immediately, switches off the relay, and then sends you another uplink or message to the network, essentially what is the current status, that it's on or you have switched it off. Yeah.
Can you also send a downlink just to request the actual status at that time?
Yes, you can. We have I think about 20 different get commands. So we have get commands where you're getting something, retrieving, or you have a set command where you want to set something.
Okay, great.
So whatever get command you send, you're gonna get the full 𝗶𝗁, which includes temperature, relay state, voltage, current, and everything.
Excellent.
Yeah.
Great. Thanks a lot. I then have a final question, and it's always a typical Dutch question, actually. Actually, what cost components will be involved, and maybe I can shine a light on that as well. So talking about costs, I already indicated that from an infrastructural point of view, you only need like 2 or 3 gateways. Well, of course, it depends on the building and the use case you have, but with just a couple of gateways, you already have a very good coverage in a building. So from an infrastructural point of view, that's really low, actually. It's, I mean, a gateway is like a couple of €100. So times 4, that's actually not a lot of money. And then the sensors are, well, depending, of course, on what type of sensor you get, but that's a few hundred from like under the 100 to a few hundred, depending on the complexity of the sensor. So that's actually the whole thing you have to take into account for such a actually good solution to retrieve all that kind of information. And as said, if you start with the objective of this kind of solutions, and you know what is the value of the information I got from this monitoring, for example, then you can really have a good judgment on the investment, and then you will see that the business case will pay off very soon. So well, that's actually more or less what it is. Let me share the final slide with the contact details of both companies. I would really like to thank you, 𝗬𝗻𝗓, for joining us on this interesting webinar. And thanks to all the participants of the webinar. And if you have any further questions, please don't hesitate to give us a call or send us an email. And as said, this webinar will be recorded as well. And the email with the link of the recording will be sent to you later. We hope to see you next time, and take care, and happy IoT.
Thanks, Jan.